Okay, so now hopefully you are all still conscious after the IP version 4 lecture, or maybe you've taken a break before coming back and subjecting yourself to this lecture. What we're going to talk about now are a couple of the other settings that we use for the internet, for IP connectivity, and then we're going to talk about some of the utilities that we use to get information and make changes to our IP settings. So, first, let's get to our connection. Go into our Ethernet connection, go to Properties, and then IP version 4 Properties, and go in here. So, we've already talked about the IP address, our 4 octets, our subnet mask, which we use to filter through what is our network numbers, and the default gateway, which is essentially our router, which is what we need to get out to the internet. Now notice one of our options here, which is the default option, is to obtain an IP address automatically. Now what this means is that we have a device, which is almost always our router, but if it's not, if it's in a larger network, it'll be a server somewhere that'll be handling this. There's a server out there that is going to automatically assign addresses based on the network. So we configure this server to say, all right, you are now in the 192.168.126 address network. So when machines log in and they try and connect to the network, you're going to see if they have an address. If they don't, you're going to give them a free address somewhere in this network, anything that's not being used. So there's a computer out there whose sole job it is to keep track of what addresses are being used by what computer. Those are called DHCP servers. DHCP is Dynamic Host Control Protocol. So it basically automatically assigns an address to a machine when the machine turns on from a pool of available addresses that it has. It keeps track of which ones it wants to send. So DHCP not only does that, it automatically assigns a couple of other pieces of information too. One of those pieces is the DNS server. We got a lot of acronyms going around here. IP, Internet Protocol, that's what we use to connect to the internet. DHCP, which is the protocol that allows us to automatically assign addresses, subnet masks, default gateways, and DNS servers. DNS server is a domain name service. Domain name service is what allows us to type in www.amazon.com instead of Amazon.com's IP address. Because IP is how we address things out on the internet. But you and I aren't going to remember all these numbers. We just aren't. And so they came up with this system to where we can translate words into IP addresses. So www.amazon.com, there's a server, there's actually a bunch of servers out there that have this information. You type in www.amazon.com, you hit enter in your browser goes out and says, hey, anyone know what this address is? And one of the DNS servers is going to say, yeah, I got Amazon's address right here. And then it takes that and it translates it into the actual 4-octet IP address that Amazon uses. And then that's what your computer is sending its data. So that's what the domain name service is. If we didn't have a domain name service, we would be typing in a lot of numbers and probably getting them wrong very often to try and connect to other computers out on the internet. This is also useful inside and local networks too. We can use names for servers instead of addresses, instead of just numbers. Along those same lines, if we click on the advanced settings here, you're going to see a couple of other tabs. So the DNS tab will give us a list of the DNS servers that we have available to us. So there aren't any listed here, but that's okay because really what this is additional DNS servers because we have them assigned automatically. If I wanted to add additional ones and I knew DNS addresses, which I actually do, I can add one. So for example, 8.8.8.8, that's one of Google's DNS servers. So if I click add, this is going to be an additional place to look for information. Now, why would I do this? Well, DNS servers sometimes go down. Many times when you find out the internet is quote unquote down in an area, it's usually, not always, but usually because there's something wrong with the DNS settings. If the DNS server in your area, the one that you rely on, is down, you're not connecting to the internet because whatever you type in, you're typing in letters and words, they're not getting translated. We're not getting the actual number. We're not getting the address back. And so that number doesn't get sent back to you. You don't send your information to where it's supposed to go. So those are DNS servers. Now, Windows name service, this is an old legacy version of DNS that was specifically used for Windows addressing only internally. This is not used anymore. It's still here because there are some legacy systems that still use Wins, I guess. Honestly, I've never had to work on them, so I'm not really sure how many are left, but I'm sure there are some. And so Windows 10 still has this old legacy naming system, but it's only good for Windows, it's only good internally, and it's probably not going to be used for much longer. I would be very surprised if in a few years we still have Wins tabs in our TCP/IP settings. So just to sum up the three different additions that I was just talking about, we have DHCP, which automatically assigns our addresses. We have DNS, which translates our names, our words, our HTTP addresses into octets, into numbers, so they can be routed out to the internet and get to the correct location. And then we have Wins, which is an old legacy version of DNS that doesn't work out in the internet. It only works internally, only with Windows machines. So if you're running Linux or Mac, you're out of luck. You're not using Wins. So those are the three additional pieces. Now, one thing about DHCP, sometimes DHCP doesn't work. Shocking, I know. But when it doesn't work, when it doesn't have an IP address to give you, or when it just fails to give you an IP address, your computer is sitting there waiting patiently for it to receive the IP address. Well, if it doesn't get it, if DHCP is down or not configured or full, after a while, your computer gets impatient and just gives up and assigns itself its own address. This address, and you'll see it in your book, is a 169.254.something address. If you ever see an address, a computer with an address 169.254.something, you know instantly that it tried to get an address from DHCP and failed. So that means it will never connect to the internet. It can't. That is not a routable address. It's called an APIPA, automatic private IP address. That basically means I need an IP address so some of my services can continue to work, because some Microsoft Windows services need an internet address to function. Doesn't mean they're actually going to go talk to anybody, but they need an address to function. So it will create this address just so things don't break, but you're never actually going to be able to use it on a network. Well, unless everyone has the same problem and everyone's on the 169.254 network. But then you've got other problems. Then you know DHCP isn't working for anything. So if you ever see that, that's just one of those troubleshooting tips. If you ever see an address that says 169.254 or something, you know there's something wrong with your DHCP server. Okay, so that's it for the different parts of an IP address. We've got IP address, subnet mask, gateway, DNS, DHCP if we're using it, and Wins. Okay, so let's get to the IP commands, the IP utilities. Most of these are on the command line. Yes, I can hear the groaning now, I know. But again, these have been used for a long time. These are going to be functioning good commands. So I showed you in the earlier video ipconfig. ipconfig, when I hit enter, gives me IP configuration for my machine. If I use ipconfig with an additional switch, the all switch, when we add things to a command in the command line, that's called a switch. It changes what this command does. This command will produce this information here, but if I have /all after that, it's going to give me more detailed information about my connections. So hit enter, and oh boy, look at all that. All right, so if I scroll back up, let's get to our Ethernet 0 adapter, which is the one we're using. So here's Ethernet 0. You'll notice this is the address that we had. This is the same as you saw before. Subnet mask here. Here's the default gateway, but now notice we have a DHCP server here. This is the computer that is giving us our address. And here is the DNS server. In this case, the DNS server is the same thing as the gateway. That's pretty common on smaller systems, or in this case, on a home router. They're not always the same, though. Sometimes a DNS server will be a different place. The Win server, same thing. So you get more information when you do that /all. You can get DHCP, DNS, WINS information on the command line by doing that. Okay? So, come back down here. All right. So some of the other utilities that they mention in the book, I'm just going to go over a few of them because you can read the book and get these information also, is hostname, for example. Hostname, if I just do that and hit enter, it tells me what the name of my computer is. Now, every computer has a host name. This name is how you internally can access the computer. So in this case, desktop, this is something that Windows made up for me. I didn't name my computer. We can talk about how to change name of your computer in just a minute. So one of the other tools that we can use is a tool called Ping. Ping is a very simple utility. All it does is it checks to see if some other computer is alive and responding. So I can ping using an IP address or an actual name that will then get translated by my DNS server. So let's do that. Let's ping www.google.com. So when I hit this, Ping is going to send 4 packets. Pings, think of it like sonar with a submarine, which is actually where this whole ping comes from, is it sends out this high-pitched ping sound, goes out. If it hits something, it's going to bounce back, and then the submarine is going to see that their ping hit something. That's sonar. That's how they detect what's around them. So Ping is going to do the same thing. It's going to send out a packet to google.com and see if it gets an answer, see if it hits it and is returned. If it is, then we know Google is alive and well. So let's see what happens. Now, sometimes, before I hit enter, sometimes companies don't allow you to ping them because they get enough traffic and they don't want to bother answering your ping because they have to actually respond. You ping them, you're saying, hey, are you there? They have to respond saying, yes, I am. And that takes time if you've got several billion people trying to ping you at any given time. So there we go. As you can see, what's happening is I'm getting a reply from an address. What is this address? This is one of Google's IP addresses. So DNS translated www.google.com into 172.217.4.100. That's one of their servers. I pinged with a little piece of data, and I got a reply. I pinged 4 times. I got 4 replies from that server saying, yes, I'm alive. It took 14 milliseconds. That's pretty fast, 13, 14, 15 milliseconds. That's a pretty fast response time. So what we've determined is Google is indeed alive. Why is this useful? Well, if you can't reach a computer, if you can't reach a server, for some reason you think things might be down, you can always ping. You can always ping and see, are you awake? Are you alive? If they are, and you still can't access the website, you know it's some other problem other than them being down. It's not their fault. So Ping is one of the many tools that we use. Now, a couple other tools that I'm going to stick with just specifically from a Windows point of view. One is called GetMac. GetMac is short for Get MAC Address. Now, a MAC address is a physical address. It's a physical number that's attached to your network card. So what I mean by that is every Ethernet card, every Wi-Fi card, every card that has the ability to connect to a network has a unique physical address, a unique physical number. So this number, it's hexadecimal. So this is 6 sets of 2 hexadecimal numbers. That is the unique address of your physical card. Why do we have these? Well, every card needs to have a specific address because I could have 2 or 3 different types of cards or different types of connections on my computer. I could have an Ethernet connection and a Wi-Fi connection and a Bluetooth connection. And my computer will have 3 different places that information can come into it. So we need to have a physical address to differentiate between different machines. So my machine has this physical address. And your machine is going to have a different a different set of numbers, a different physical address. They're all technically supposed to be unique. In reality, they're not, because we have too many devices in the world and too many numbers that we will run out of actual unique numbers. But that's okay, because it's really hard to find some things that have the same number, and they're generally not going to be in the same network location. So we shouldn't have duplicates. Just like there's more than one 13 Elm Street addresses in the United States, they're not all in the same place. One is in one city, one's in another city, so you're not going to run into a problem where you've got two homes with the exact same address. You're not going to have two of these internet connectivity points, any of these devices with the same address nearby each other. Okay? So a MAC address is a physical address of the port on your computer. So GetMac will show all of the different devices. Notice I have two. I have a Wi-Fi that is not connected, and I have my Ethernet connection that is connected. Now, of course, we do have to be able to map these physical addresses to IP addresses because, like I said, IP is how we talk to other machines. So we have this thing called ARP, A-R-P, Address Resolution Protocol. This translates IP addresses to MAC addresses. This is similar to DNS translating words into the actual IP address. This does the same thing, but it does it for IP addresses and physical MAC addresses. Whoop. And of course, I actually need to specify my address. So a quick IP, and I shouldn't have hit enter there because now I've got a big mess. So if I hit IP config, that's my address. So if I want to configure, if I want to see what my address is, I'm going to ARP, and then I'm going to use the flag A. This is going to actually display my full ARP table, my address resolution protocol table. So my computer, these are all of the IP addresses and the physical MAC addresses that it knows about. It keeps track of these, all of the ones that it sees most often. So this, if you remember this number, is our default gateway. So my computer knows that the default gateway has a physical address, has a MAC address of this, which is kind of weird, hard to read. My DHCP server, which is what this was, has a different physical address. You see, they're not the same thing. So as we can see, we need to translate these internet addresses to physical addresses so the computer will know which port, which actual physical piece of hardware to send the data, which data it's, and also the other way around, where the data is coming from. So those are a few of the command line tools that you can use. Again, the book has a few more things. It has traceroute, pathping route, netstat, and I'm forgetting a couple of the others, but there's a bunch of them, and they give description of what they are and how they're used. I expect you to understand what they are and to know more or less what they do. Do I expect you to memorize them and be really proficient with them? No, that's probably beyond the scope of this class. However, if you are interested in taking the certification exam that's related to this class, you will have to be familiar with what these commands are. Again, they're probably not going to make you type in too many of them, but you should be able to recognize them and answer questions about them. So that's going to be it for this lecture of the different tools and the extra settings that we had for the IP version 4 addressing. The next and last video for this week, we are going to talk about file sharing and a little bit about wireless networking in Windows 10.